Hello, so this video will start chapter 3, which is on ionic compound. So we will cover section 3.1 and 3.2 in this video. So the first section, 3.1, is an introduction to bonding. So bonding is a chemical term to say that it is the joining of two atoms in a stable arrangement. So elements will gain, lose, or share electrons to obtain an octet. An octet means 8 valence electrons, like the noble gas closest to them in the periodic table. So we learned that noble gases are very stable atoms, and they do have 8 valence electrons. They are in group 8A, and the group number is the number of valence electrons. So except for helium, they all have 8 valence electrons, and that makes them very stable. And so all other elements will try to be like them. And for this, they will have to either gain electrons or lose electrons or share electrons. And the goal for the other elements is to be like the next noble gas or the previous noble gas, the one that is closest to them in the periodic table. And so to gain, lose, or share electrons, elements will bind together with other elements. And there are two different kinds of bonding. There is the ionic bondings and the covalent bonds. Ionic bonds results from the transfer of electrons from one element to another. So transfer really means a complete departure from the initial element to go with another element. Covalent bonds results from the sharing of electrons between two atoms. So in this case, the atoms keep their electrons, but they share them. And this way they can get 8 electrons around them. So more details on what is ionic bonds. So ionic bonds will form between metals and non-metals. And maybe you remember from chapter 2 that metals are located on the left side of the periodic table, on the left side of the zigzag line, and non-metals are located on the right side of the staircase line. So when you have an element from one side of the periodic table and from the other side of the periodic table, if they bind together, it will be through an ionic bond. Like, for example, NaCl. Na is a sodium found on the left side of the periodic table. And chlorine is a non-metal from the right side of the periodic table. And so as element, sodium is a metal, it's a solid. Its single atoms are packed together in a regular arrangement because they are solid. And it's a soft solid. You can see here that someone is able to cut some of the metal with a knife. It's a soft metal. And chlorine as an element is found as Cl2, what we call a diatomic molecule made of 2 atoms of the same kind. 2 Cl atoms bonded together form the gas chlorine, the chlorine gas. And so both sodium and chlorine by themselves are very toxic. If you were to take a piece of sodium metal and swallow it, it would burn your inside. It would react with the water in your body, and it will be a explosive reaction. And chlorine gas, the chlorine gas is the mustard gas that has been used in wars to kill people, like in the trench during World War I. Between France and Germany, they used the chlorine gas to kill soldiers in the trench. So anyway, you would not want to swallow any of them as an element. But if they are combined and binding together, they form NaCl, which is table salt. And table salt, we put it on our food and eat it every day. It's great food taste enhancer. And so when they are bonded together, they form this white crystal, and it's an ionic bond when they are bonded together, because one is a metal, the other is a non-metal. Covalent bonds are formed when two nonmetals combined or when a metalloid bonds to a nonmetal. So covalent bonds are formed between nonmetals, which are found on the right side of the periodic table. And whenever atoms bind using covalent bonds, we call them molecules. So a molecule is a compound or element. We've seen that it can be an element if it's two atoms of the same kind, like illustrated here with hydrogen. And so a molecule is when you have two or more atoms joining together with covalent bonds. So covalent bonds and molecules will be discussed in more details in chapter 4. So one thing I want to say is that covalent bonds are formed when electrons are shared between atoms. Here in the example, the two hydrogen atoms, they have each one electron only, because hydrogen is atomic number 1, has 1 electron. And so hydrogen is an exception. It likes to be like helium, the noble gas helium, and have 2 electrons in its valence shell. And so to get 2 electrons around it, hydrogen will need to share with another hydrogen atom, and together, by sharing their electrons, they each have 2 electrons around them, and that makes hydrogen happy. So the electron clouds of the two hydrogens are overlapping. You can imagine the atoms as spheres that have no outer bond, and when they overlap, in the zone of overlap, that's where they can share their electrons. And so when they share electrons, we call that a covalent bond. So now we will focus on ionic compound. This chapter is about ionic compound. And ionic compounds are made of ions. There are 2 types of ions. There are the positive ions and negative ions. The positive ions are called cations, and the negative ions are called anions. And so, more generally, ions are called ions. Ions are charged species in which the number of protons and electrons in an atom is unequal. So it's when you have an imbalance of charges, and so they show up as charges for the molecule or the atom, and then we call them ions. So ionic compounds consist of oppositely charged ions that have a strong electrostatic attraction for each other. So oppositely charged means that an ionic compound is made of positive ions bonded to a negative ions. And the reason why they are attracted to each other is because opposite charges attract, right? Positive charges are attracted by negative charges. So the cations will be attracted by the anions due to a strong electrostatic attraction. And that's how ionic compounds are forming. So we'll review in more detail what it means to be an ion, and let's start with cations. Cations are positively charged ions. A cation has fewer electrons than protons. So let's look at an example. The sodium atom, Na, atomic number 11 has 11 protons in its nucleus and 11 electrons in its electron cloud when it's the neutral atom. And so when sodium loses one electron, then it goes from 11 electrons to 10 electrons. But it still has 11 protons, right? Because the identity of sodium is not changed. It still keeps its 11 protons in the nucleus. And so now we have 11 protons and only 10 electrons. So 10 of the positive charges will be cancelled out by the electrons, but one of the proton will have its positive charge not being cancelled by an electron. And so this will show up as a charge for the sodium, and it will become the sodium ion. So the sodium cation is Na+. And by doing this, Na becomes like neon. If you look at neon in the periodic table, its atomic number is 10, which means neon has 10 electrons. And by losing an electron, the sodium atom becomes like the neon atom. It becomes like neon as far as a number of electrons are concerned, because now it has also 10 electrons like neon. And that stabilizes sodium a lot by doing this. It's much more stable than having one electron in its valence shell. So by losing 1, 2, or 3 electrons, an atom forms a cation with a completely filled outer shell of electrons, an octet. That's the goal of all elements when they become ions. It's that they will reach this state where they have a full valence shell of 8 electrons. So let's look at another example of a cation, the magnesium atom. Magnesium, atomic number 12, has 12 protons in its nucleus and 12 electrons when it's the neutral atom. Magnesium likes to lose those 2 electrons that are in its valence shell. And by losing 2 electrons, it goes from 12 electrons to 10 electrons. But it still has 12 protons in the nucleus. So 10 of the protons will be cancelled out by the 10 electrons, but you will have still 2 protons that are not cancelled out. And this will show up as a 2+ charge for the magnesium ion. So magnesium likes to become a magnesium 2+ ion because now it has 10 electrons. And again, it's to be like neon. By having 10 electrons, it is like neon who has 10 electrons. And that means magnesium this way has only 8 valence electrons in its outer shell. And it's not only, it has 8 valence electrons in its outer shell, and that makes an octet, and that makes magnesium happy. Anions, they reach this happy state of having an octet by losing electrons, gaining electrons. Anions are negatively charged ions, and an anion has more electrons than protons. So let's look at chlorine. The chlorine atom, chlorine atomic number 17 has 17 protons in its nucleus and 17 electrons in its electron cloud. For chlorine, it is easier to gain 1 more electron to have 8 valence electrons in its outer shell. And so from 17 electrons, chlorine likes to become Cl- and gain 1 more electron. So 18 electrons for the Cl- ion. 18 electrons versus 17 protons. That means one of the electrons is not cancelled out by the positive charges from the protons. So then this one negative charge shows up as the negative charge on the chloride anion. And so chlorine likes to become the chloride anion with one negative charge. And by doing this, it becomes like argon. If you look at the periodic table, chlorine, by gaining one electron, it has 18 electrons, just like argon. So that's what chlorine likes to do, because argon with 8 valence electrons in its outer shell is very stable. So there is an easy way to know what kind of ions the main group elements become. It's by using the group number. So what you have to remember is the octet rule. The octet rule says that a main group element is especially stable when it possesses an octet of electrons in its outer shell. And it's really what all elements try to do. It's to get an octet of valence electrons around them. That will make them very stable, just like the noble gas are. And so elements of the same group will form ions of the similar charges. So metals, those elements on the left side of the periodic table, form cations by losing electrons. And these are predictable ions if they are from group 1A, 2A, and 3A. So remember, the group are the colons. And so for those metals in group 1A, 2A, and 3A, the group number equals the charge on the cation. So it's easy to remember what kind of cation they become just by looking at which group they are in the periodic table. Nonmetals, they like to form anions by gaining electrons. And for the main group elements that are nonmetals in group 5A, 6A, and 7A, to obtain the charge on the ion, you do 8 minus the group number. So for example, 8 minus 5 will be 3. And so group 5A will typically have 3 negative charges when they become ions. 8 minus 6 will mean 2 negative charges for elements from group 6A. And 8 minus 7 will be 1 negative charge for the halogens from group 7A. Let's look at this in more details. So let's start with metals from group 1A and 3A. So metals become positive ions and the cation charge is equal to the group number. So let's look at group 1A, which are the alkali metals. The alkali metal, we know now from chapter 2 that the number of valence electrons is equal to the group number. So in group 1A, those metals they have 1 valence electron. And so the Lewis structure would show the metal element symbol with 1 dot. So M here represents the alkali metals, which are lithium, sodium, potassium, rubidium, cesium, and francium. And so they like to lose that 1 valence electron and become +1 ions by losing 1 electron. And so the alkali metal become +1 ions. In group 2A are the alkaline earth metals. These are beryllium, magnesium, calcium, strontium, barium, and radium. And so they have 2 valence electrons because they are in group 2A, means that they have 2 valence electrons, and the Lewis structure looks like this with 2 dots to represent those 2 valence electrons. And so those alkaline earth metals, they like to lose those 2 valence electrons and become 2+ ions. In group 3A, the metals have 3 valence electrons, so they are represented with 3 dots. And they like to lose those 3 valence electrons and become 3+ ions. And so be careful here, it's only for the metals in this group. So boron is not a metal, it's a metalloid, so it's not pertaining for, it's not true for it. It only is true for aluminum, gallium, indium, and thallium. And so now for non-metals in group 6A and 7A, even 5A, the anion charge is equal to 8 minus the group number. So for group 6A, they have 6 valence electrons. Remember, the group number equals the number of valence electrons. So this is element oxygen, sulfur, and selenium, right? We only talk about the non-metals here. So tellurium and polonium are not included. So for sulfur, oxygen, and selenium, they start with 6 valence electrons. And so if you do 8 minus 6, it's 2. They like to gain 2 electrons. And so from 6 dots around them, they gain 2 more and they get an octet. So now you can see that they are surrounded by 8 dots, which means an octet. And those 2 extra electrons show up as a 2 negative charge. And we can, Group 7A, the halogens, have 7 valence electrons, so 7 dots around them. They like to gain 1 more electrons because we do 8 minus 7 is 1. So they like to gain only 1 electron, and that will help them reach the octet. Now they have 8 dots around them with 1 extra negative charge. And so the halogens are fluorine, chlorine, bromine, and iodine. They will always make -1 ions. So this is summarizing what we covered here. And these are all what we call predictable ion. You can predict from their position in the periodic table what kind of ion they become. So in group 1A, all those metals become +1 ions. Notice how hydrogen is omitted here. It's, even though it's in group 1A, it's non-metal, so it doesn't work for hydrogen. Actually, hydrogen becomes a +1 ion too, but it's not a metal. In group 2A, the alkaline earth metals become cations with 2+ charges, because 2A, so 2+. It doesn't work for the B group. Notice how here we don't have any transition metals that give a predictable ion. Then in group 3A, we have metals there that are predictable. Because they are from group 3A, they will become 3+. And these are aluminum, gallium, and indium. Now, for the anions that are predictable, these are from group 5A. They like to become -3. And for these, it's easy to see also from the periodic table, from their position. So we do 8 minus 5 and we get 3, right? But you can also, looking at the periodic table and, for example, nitrogen, if you count the number of steps that you need to reach the next noble gas, you will take 3 steps to the right. So from nitrogen, 1 step to oxygen, 2 steps to fluorine, and 3 steps to neon. Neon is the noble gas in that row. So by gaining 3 electrons, nitrogen will have 10 electrons like neon. And so that's how visually you can also remember the charge they will have. So group 6A have two negative charges when they become anions. And you can see there is 2 steps until you reach the next noble gas. So they need 2 extra electrons to be like the next noble gas. And then the halogens always become a -1 ions because they need only 1 more electron to be like the next noble gas. So these are predictable ions, which means they will not be given to you. You will have to remember to how you can retrieve their symbols. Now, metals with variable charge. I said that the B groups, the metal in the B groups, which are called the transition metals, these give different kinds of ion. They can have different kinds of charges. Like, for example, chromium can be 2+ or 3+, iron 2+ or 3+, copper can be +1 or 2+, etc. So they form different kinds of ions. They are not predictable. So we call them metals with variable charges. And typically, these are the transition metals. Notice how group 3A here are not in this table because they are predictable. But then group 4A are not predictable anymore. So tin, Sn will give ions that are 2+ and 4+. And lead, the symbol Pb, can be 2+ or 4+. So these are variable charge metals. So it's all the transition metals and also the metals from group 4A and 5A. So these are not predictable. So there will be some information that will allow you to find what kind of ions they are when they form compound. So if we focus on the human body here, the common ions in the human body are, from the minerals we saw previously that were major nutrients and minor or traces elements. And so calcium is a major mineral that is needed and found in teeth and bones. Iron is present in the hemoglobin in the blood, and it's used to carry oxygen. Chlorine is found in the gastric juices of the stomach and other fluids. Magnesium is needed for nerve transmission and muscle control. Calcium is also necessary for muscle control and nerve transmission. Sodium and potassium are found in all body fluids. So potassium and magnesium are present in high concentration inside the cell, so in the intracellular fluids, while sodium and calcium are in higher concentration outside the cell, so in extracellular fluids. So let's go through some learning check here to help you remember how to find what kind of ions elements become. So it is a good habit here to pause the video, put the effort into answering the questions before you watch the answer. So select the correct answer for each. What is the electron change needed to obtain an aluminum octet? So here we have aluminum, so you want to find it in the periodic table. And aluminum is in group 3A, it's atomic number 13. So aluminum is a metal, it's under the staircase line. Remember that even though it touches the line, it's a metal, not a metalloid. So aluminum, group 3A, is a predictable ion, and it likes to lose those 3 valence electrons to become an ion. So it will lose 3 electrons So then its valence shell will be the previous shell with full with 8 valence electrons. What is the charge of the aluminum ion? So when you're losing electrons, you still have the same number of protons. So now you have some protons that are not cancelled out anymore. And so that means you will have 3 positive charges showing up, right? Because aluminum still has 13 protons and now it lost 3 electrons. So it has only 10 electrons, like neon. So those 3 extra protons will show up as 3 positive charges for the aluminum ion. And so the symbol will be Al3+. Let's do another one, this time with nitrogen. Again, pause before you watch the answer. So what is the electron change needed to obtain a nitrogen octet? So find nitrogen in the periodic table. Nitrogen is a nonmetal. It's on the right side of the periodic table, atomic number 7, in group 5A. So group 5A means it has 5 valence electrons. To reach an octet means 8. So you do 8 minus 5 is 3. So nitrogen needs 3 more electrons to be like neon, the next noble gas. So it will gain 3 electrons. Now, when nitrogen gains 3 electrons, it still has 7 protons because its atomic number is 7, means it has 7 protons. And this has not changed. When they become ions, the elements keep their number of protons the same. So 7 protons versus now 7 plus 3, 10 electrons. So you have 3 electrons that are not cancelled out by the protons anymore. So these 3 electrons will show up as 3 negative charges. And so the symbol will be N3-. So which noble gas is nitrogen trying to be like? So nitrogen, you can see, is in the row where it ends with neon. And so when nitrogen gains 3 electrons, it goes from 7 to 10 electrons. And 10 electrons, that's like neon. So nitrogen likes to be like neon. One more practice problem here. Provide or select the correct answer for each. So what is the group number for sulfur? Again, pause the video before you watch the answer. And pause the video to try to answer yourself. So what is the group number for sulfur? Sulfur is found on the right side of the periodic table, atomic number 16, and it's in the group 6A. How many valence electrons are in sulfur? Sulfur being in group 6A means it has 6 valence electrons. Remember that the group number equals the number of valence electrons. What is the electron change needed for sulfur octet? So sulfur, like any other element, likes to be surrounded by 8 valence electrons. It has 6, so it needs 2 more to have 8 around it. So sulfur will need to gain 2 electrons to be like the next noble gas. And so what is the ionic charge of an ion of sulfur? So now sulfur with 2 extra electrons. So it will have from 16 electrons now 18 electrons. And it still has 16 protons. So those 2 electrons that are in addition to the 16 protons, they will not be cancelled out and they will show up as a 2 minus 2 negative charge for sulfur. So which noble gas is sulfur trying to be like? So if you look at the end of the row where sulfur is, it's argon. By gaining 2 electrons, sulfur goes from 16 electrons to 18 electrons. And argon is the noble gas that has 18 electrons.